I've glued down one servo, just using hot glue, onto a flat surface, in this case just a piece of foam board. And what I want to do is get other servos aligned so that the axes are at 90 degrees. So the first one, this one is going to be my yaw rotation. This one will be at 90 degrees from this axis, so those axes are orthogonal. And what I'm going to do is have that one set up here, and that will be the pitch, and then a third one will be the roll, which I'll glue later. Okay, so here's how I've glued the other piece onto the other servo. Notice that this point where the axis or the servo is going to connect is aligned with the axis of rotation of the servo. So what I'm going to do is I'm going to put this on here at as close to orthogonal on these axes as I can, and that will give me my pitch rotation axis. And this servo is going to serve as the roll control. So I want the axis of this servo to be the x-axis of the airplane. So I'm going to put it on there this way, and I want this axis, this x-axis, to be orthogonal to the y-axis shown by this servo, and I want to get these aligned like this. So I'm going to take and hot glue this piece onto this servo here so that it'll fit orthogonal. So I'll put a little bit of hot glue on here. And then get this so that this point is aligned with that axis of the servo. And then I can mount this. Let's try. Mount this right here. Now I've just created something to visualize the airplane. So this piece is going to go on the last axis of rotation here, and that will represent our airplane, so that we can visualize what the Euler angles actually translate into in terms of the position of the plane. So I've just hot glued the servo connector onto a couple of pieces to firmly fix it to a popsicle stick. And then this would be the wings of the airplane, and this would be the fuselage. So the next thing to do is to get the servos ready to connect to the Arduino.
What I have here is a demonstration of how Euler angles work. So we have 3 servos that do our Euler angles, and we have a representation of the airplane given by these popsicle sticks. So here's our fuselage, and this is our wing. And right now we are as close to the inertial 0 as I can get it, because I can't get it exactly because the splines on the servos allow me so much resolution. So anyway, this is as close as I can get it to being straight and level flight for the airplane. So it's actually banked a little bit to the left. So a little bit about how the servos are connected up. So each servo lead has a power and a ground and a signal wire. The signal wire I'm driving with the pulse width modulation from the Arduino Nano board, and the power and a ground I'm driving from a LiPo battery. I'm only using one cell of the LiPo battery. If I try to drive it from the 5 volts coming off of the Nano, because this can't supply very much current, you get some erratic results. But if you just use the voltage coming off of one cell of a LiPo, which is nominally 3.7 volts, that's enough to drive a servo, then that's enough to power your servo. So the power and ground come from this LiPo battery, one cell, and the signal wires come from 3 pins that I'm using to drive the pulse width modulation from the Arduino Nano. So let's see what happens when we actually make some commands to the system. So if I give it, if I give the system a 30-degree angle in yaw, we should see a rotation in yaw. So there's 30 degrees of yaw axis rotation. And now if we want 45 degrees of pitch, we should see the plane pitch up by 45 degrees. And now if we were going to roll, say 20 degrees, we would see a roll of 20 degrees. So this is now the body axis, and that's how we go through the Euler axis transformation to get from the inertial axis, which is what we started with, to the body axis, going through the coordinate Euler axis transformation. So this is the program that I put together to implement the Euler axis demonstration, or the Euler angle demonstration. And you can see it's a fairly simple piece of code, and this uses the Arduino integrated development environment, which is free. So what's the expense of doing this little demonstration? Well, there's 3 servos here, and if you look around you can find servos fairly cheap. So here is a couple of them for about, well, there's one for $2.34 each. So for $7.50 you can get those. Then the Arduino Nano board from that same supplier. Here it is on their website, and $12.39. So now we're up to about 20 bucks. Then you need a LiPo battery, which you can get fairly cheap, a couple bucks, and then some wires in order to make the connections, which should be fairly inexpensive. So somewhere on the order of 20-25 bucks, you can do this demonstration. So what can be learned by doing this demonstration? Well, first of all, you learn what's involved in reference frame transformations and how Euler angles are implemented in aircraft to give you a transformation from one reference frame to another. Additionally, you get an understanding of how servos work. Since you're driving it with an Arduino, you get an idea of how those microcontrollers work, and how to program them using the Arduino integrated development environment.